Go.
Hey guys, my name is Firefighter Nguyen. I'm with the Travis County ESD 12. I am doing my Instructor 1 presentation on fire behavior and its component. So this presentation will go over overview and the content outline. So presentation will cover fire behavior. The fire behavior triangle is the major component of weather, topography, and fuels. This presentation will also review and address what constitutes as a red flag warning and its characteristics. The outline is going to have introduction, fire behavior triangle, topography, fuel, weather, red flag warnings, and conclusion. I chose this because I don't know if you guys were here a couple months ago. We were experiencing red flag warning days for weeks and weeks, and no one knew what that meant. We remember we had to ghost our brush truck and be super vigilant and all the grass fires we were getting. So that's why I chose this topic. So the learning objective for this presentation is identify the three components of the fire behavior triangle, understand how weather, topography, and fuels affect fire behavior, understand how fuel size, arrangement, and continuity contributes to fire spread, understand what a red flag warning is and its component and why it's so dangerous. So introduction. So there are many key variables that dictate how a fire behaves. These include the three major components, weather, topography, and fuel. Sorry, I'm having a problem with that word for some reason. In this presentation, you will learn these three major components and how it affects the fire's behavior. You also learn what a red flag warning is and why it's so dangerous. So the first one is, God dang it. There we go. Okay, so the fire behavior triangle. Similar to the three components of the fire triangle of heat, fuel, and oxygen, what you learn Fire Academy 101, right? So there's also three components for the fire behavior triangle. So weather, topography, fuel affects the fire behavior. So listed below are the three components. Topography, which is the elevation, slopes, or steepness of slopes and aspects. And then the second one is going to be fuel availability, continuity, and arrangement of the fuels. And then weather is going to be temperature, relative humidity, wind, and precipitation. So aka rain. So the first one is going to be topography. Topography refers to the shape and surface features of the earth, such as mountains, valleys, canyons. In this presentation, we'll go over the elements of topography, such as slopes, elevation, and aspects, and how these elements affect how a fire spreads, moves, and behaves. The influence on fire behavior is generally more predictable than other factors like fuel and weather, as these features are less subject to rapid change. So what it's saying is it's not going to change as much as weather. We live in Texas. The weather changes every hour. Yesterday we had like 50, 60 degrees, and now it's 90, and then next week's gonna be 100. So it's not so like the shape and surface of the earth is not gonna change as fast. It will probably take decades and not hundreds of years to change. So the first one is gonna be slope. So what you need to know about slope is the fire generally spreads faster uphill because fuels are more efficiently preheated by uphill spreading flames and heat. This is caused by fuel being closer contact to the fire due to being at an angle compared to a flat surface. Additionally, the steeper the slope and the more fuel, the faster the fire will burn. So what you just imagine a slope, right? Like right here. So since this is at an angle, the fire goes up, right? So all these fuel right here are getting exposed to the fire, more exposed to compared to if this was flat. So this is getting preheated, and we'll go over what the preheating effect is. This is the closer the flames are to the fuel, the more effectively they preheat it, leading to faster spread and increased intensity, especially on the steeper slope. So when the smoke and flame and heat is going that way, this has been preheated. This is all the moisture is getting dried up. And then when you get wind, which pushes the fire up, it just escalates things, right? So all this is getting dried up, they're ready to ignite, and then the wind pushes up the hill. That's why whenever we roll up on the scene and you see a hill, the fire is, you're not going to catch up to it because it has all these factors playing into it. So another concern that we need to know about slope is sometimes if this tree is on fire, since it's uphill, sometimes it'll roll down and start fires down here or somewhere else. So we need to be concerned about chasing it, right? So let's say we chase it up here and then debris or flame goes down here, so it's going to start a fire behind us. This is what we need to know about or worry about. Okay, so another feature is aspect. So aspect is the compass direction of terrain surfaces such as south or north facing slope. So south and southwest facing terrain receives a little bit more sunlight, leading to higher temperature, lower relative humidity, and drier fuels, which in turn increases the likelihoods of ignition and faster fire spread. And then north and northeast facing slope, on the other hand, tends to be cooler, shadier, and more humid, potentially slowing down fire spread. A good example is this, if you ever go to like a colder state with like, let's say Colorado or like, I don't know, you're from Maine, right? So you see a lot of snow. So when you buy a house up there, you want to buy a south-facing house, so south of facing to the sun, because the snow will melt, the sunlight will melt the snow, compared to a north-facing house. It's going to take a little bit longer for that snow to melt because it doesn't have contact with the sunlight. So unless you want to, shovel snow, choose a north-facing house. So same thing with aspect. So let's say a slope is south facing, so it's going to be easier to ignite. It's going to spread faster than a north facing slope. And then the next one is elevation. So elevation is the height of the terrain above mean sea level. Elevation affects what kind of fuel a terrain surface will have and how much of it. Fuel will dry out earlier in the year at lower elevation when it's warmer than at higher elevation. At higher elevation, snow tends to linger, which affects the moisture of the content of the fuel. So this is what it's saying is like the higher the fuel in elevation, the more moist it's going to be. It's going to be harder to ignite. It's not going to spread as fast as like fuel at the lower elevation. And then what another factor is lightning strike occurs more often at higher elevation. So let's say you have a big old mountain with a lot of fuel. Lightning is going to hit that more likely than lower elevation. And then other, so saddle or passes is a pass between two ridges. They can change wind pattern, funnel air, increase wind speed, which increase fire behavior. So this is a saddle right here. So you imagine if there's a big gust of wind blowing through this. So this is going to channel all that wind right here into the saddle. So let's say you get a little ember right here. It's going to travel way faster than if it's out here because it's channeling all the wind. And so you just need to be careful about saddles. So fire barriers. So some features such as ridges, rock outcrops, streams, rivers, lakes, or roads can act as fire barriers, preventing the spread of fire and sometimes causing the fire to burn itself out. We see this a lot. When we go to a grass fire and we're chasing it and it hits a road and then it just stops and it just burns itself out because it doesn't have anything to feed on. If you look at here, you see all that fire, the fire is spreading this way, and since there's a river right here, it can't jump it, so it just kind of burns itself out. It just stops naturally. So the second component is fuels, right? So fuels are organic material that will burn in the fire. So anything organic, right? So any grass, trash, whatever, it'll consume it. Fuels can be classified as ground, surface, and crown fuels. So crown fuels are small branches of trees or any scrub up in the trees, so higher up, like here. Surface fuels are on the ground, such as branches, small grass, scrub, needles. So most of our wildland fire is going to be surface fuel because we don't have any high trees. Ground fuels or organic matter, so like underneath the ground, around the trees, like peat, decomposing tree roots. We don't see much of that. The most we're gonna see is the surface fuels. So how does that affect fire behavior? Wildland fires have many properties that affect fire behavior. In this presentation, we'll go over a few of these, such as quantity, arrangement, and continuity. Quantity means the amount of fuel in the area. More fuel, especially dry and smaller types, lead to more intense and faster spreading fires. Arrangement means how fuels are arranged, especially density, how they affect their ability to burn. If fuels are closer together, they can ignite each other and burn easier. So let's say we have a bunch of heavy logs, right, together. They're gonna all burn, but very slowly, the arrangement of it, right? Compared to if you have some like little bits of grasses, like a leaf pile, and they're all together, that's gonna burn faster than a log. Continuity is can either be continuous or patchy. Patchy areas of fuel will have spots of fuel with non-burning material in between, while continuous will have fewer or no areas of non-burning material in between. Fire is more likely and easier spread with a continuous fuel bed. So just imagine, let's say the desert, right? We have patches of grass everywhere in the like desert. There's like rocks and stuff, right? It's not gonna burn. It's not gonna spread as fast as if you light someone's lawn on fire. It's like continuous grass. It's gonna spread faster, burn with more intensity. And then weather is the last component. Weather is the most variable component in the fire behavior triangle and has tremendous effect on fire behavior because it can change rapidly and unpredictably. We witness this every day living in Texas. You know, if you don't like the weather in Texas, just wait a day or wait an hour. Because like there'll be days where it's snowing and then the next day it's 100 degrees. So that's why weather is so dangerous, because it changes so fast. So the four weather primarily influence fire through four major characteristics, right? So wind, temperature, rain, and relative humidity. So the first one is wind. Wind affects fire behavior in many ways, such as increasing the supply of oxygen to the fire, thus fueling it. Increased fire spread by carrying embers away from the fire to create spot fires, and then preheats and dries out fuel, making them easier to ignite. And then most importantly, it changes the speed, the direction of the fire, which increases the fire spread and fire intensity. So what's so dangerous about wind is it can affect any fire, right? So a wind-driven fire is going to be way more dangerous than a normal fire, because let's say we're chasing this grass fire, right? And there's a road right here. We're like, oh, cool, this road is going to block it. But if it's wind-driven, it's going to jump over and burn. It's going to leap over the natural barrier or the road, and it's going to burn the other fuel. That's why wind-driven is so dangerous. And then temperature, the main way that temperature directly affects fire behavior is by drying out the fuel, making them more susceptible to be ignited by other sources. Fire with higher temperature will burn more intensely and will have a faster rate of spread. This is the reason why wildland fires are more common during the summer, where higher temperatures are more frequent and in lower season. I don't know about how new you guys are, but like, have you ever fought a fire in the summer? It just sucks, right? And it seems like the fire spreads faster and it's more intense because of the heat. The heat also like dries out all the fuel too, so you're gonna fight more wildfire and more structured fires in the summertime than the winter. And then rain, right? So this significantly affects fire behavior by changing the moisture content of the fuel. When moisture content of the fuel increase, they are less likely to ignite. And if ignited, they will burn slower than normal unaffected fuel. Frequency has a huge impact on fire behavior, as consistent additional moisture will slow down or extinguish fire. Rain also impacts the other components of fire behavior triangle. More rain means lower temperature, makes it fuel hard to ignite. And then continuous rainfall will create or change the topography of an environment by creating rivers or bodies of water to act as a fire stop. So a good example of this, if you ever like light a sponge on fire, it's pretty easy, right? Like a dry sponge just goes up, right? But if you like put water in it, like you're gonna have a hard time lighting that on fire. So same thing, right? So it affects the moisture content of fuels. And then the most important thing is relative humidity. Does anyone know what relative humidity is?
The ratio of water vapor in the air compared to...
Nice, you can read. Okay, so it is the ratio of water vapor in the air compared to how much water vapor that the air can hold, as expressed as a percentage. So for example, let's say the relative humidity is at 50%. This means that the air is holding 50% of the maximum water vapor at that temperature. So at lower humidity, fuels become drier at night, easier, and burn more quickly. And then at higher humidity, fuel becomes wetter, harder to ignite because the fuel absorbs the water in the air. So you see right here, this is 100%, it's holding 100% of the water, 75% of the water, right? 50 and so on. All right, so why is this important? So relative humidity has an inverse relationship with temperature. So as temperature rises, the relative humidity drops. And as temperature drops, relative humidity rises, right? So this relationship is a result of warm air being able to hold more water vapor than cold air. Thus, the water vapor represents a smaller percentage of total water vapor capacity of the air at the higher temperature. So a good example of this is like, let's imagine this room, we have, I don't know, 10 people, 10 really fat people, right? They take up 50% of the room. So let's imagine 10 fat people taking up half this room. So you can say the room is at 50% capacity. You can't move anywhere, it's like 50% full, right? So let's say we change the room into like a bigger room, right? Like twice as big, but the same amount of people, the same amount of fatness, right? So it's at 25% capacity. So the room acts as the temperature, and the people are water vapor in the air. So if you look at this, let's say this is like 60%, but if you change their temperature, the ratio drops, right? So air temperature rises, but water vapor decreases. So why is this important, man? Why am I telling all this? So red flag warnings. Okay, so we had a bunch of red flag warnings weeks a couple of months ago, and I feel like we're gonna be dealing with this a lot because summer is around the corner. So the red flag warning is a warning issued by the United States National Weather Service to local fire agencies and fire managers that the condition of grass and wildfire is ideal and is for extreme wildland fires. So the condition has three components: low humidity of 25% or less, wind speed of 20 miles per hour or greater, and temperatures of 80 degrees or more. So pretty much like summer, right? So summer we're hitting like 100 degrees. So as temperature rises, right, so this drops. So we're gonna face a lot of low humidity days. And then it depends on the speed pretty much of the wind to like pick all that up and spread it. So red flag warnings indicates that there is high possibility of extreme wildland fire that can ignite easily and spread rapidly. Low humidity and high temperature causes surface fuel to dry and ignite effortlessly, while high winds can spread fire and fuel to create a fast wind-driven wildland fire. So that's why we ghost the brush truck, because you never know when wind's gonna pick up, right? So you never know when we need it, right? We don't want to be at Walmart at 100 degrees, low humidity, and high wind, and when it catches us off guard, we gotta run back and grab the brush truck. So we ghost the brush truck until nighttime comes around. With nighttime, the temperature drops, right? That means, what's that mean?
Temperature drops, means the humidity goes up.
Yep, inverse, right? So as temperature drops, the humidity increases, and when the humidity increases, what does that mean?
More moisture.
More moisture, so
fire.
like fuel are more moist, right? Like Lopez here. It's harder to ignite. And wind speed here. So three major factors, right? So that's why whenever you like come in on shift and BC's freaking out, all your lieutenants like, we got ghost suppressor, because of these 3 factors. The only thing that's missing is someone dragging their chain as they're towing a car, or they're flicking a cigarette out as they're driving by. If all 3 of these conditions are met, that's gonna be a bad day. I fought a lot of wildfire because of these 3 conditions right here. So conclusion, let's put all this together, right? Why am I here? Why am I talking to you guys? So fire behavior has 3 components, right? Photography, or photography, fuels and weather, which all affects fire behavior in its own way. I'm just gonna skip that word. Influence fire behavior with its physical features like slope aspects, as well as create natural fire barriers such as river ridges, which stops the fire. Fuel is what fire consumes in order to grow. The type of fuels and how they are dispersed has a significant impact on fire behavior. Weather significantly affects fire behavior by either raising or lowering temperature and water vapor in the air. Wind increases oxygen to the fire and changes its direction and speed. And then the most important part is red flags. Red flag has 3 components: low humidity, strong wind, and high temperature, which creates the perfect condition for extreme wildfires. So with summer coming around, we're gonna be experiencing all of this. So you roll up on scene, you see a hill and fire, you know that's gonna be a wind-driven fast fire, right? It's going up a hill. Just now you know whenever you roll up on scene. That's why the dispatch tells you the wind speed. They tell you the relative humidity. They tell you like the temperature, and that's why. That's why all the lieutenants are freaking out as fire season comes around. So that's it, man. You guys have any questions?
Cool.